பார்த்தீங்கன்னா where we going to see continuous dry friction welding and inertial friction welding. First, we see the definition of friction welding. Friction welding is a solid-state joining process that produces coalescence by the heat developed between the two surfaces by mechanically induced surface motion. In this, we generally know to join two metals, there are many different ways. One of the way is welding, and the other way is by reverting it we can join, and by screwing it. While welding, one heat source is required to melt the metal, and then it is cooled so that the two metals can be joined together. This is the basic principle of welding. In friction welding, heat is generated by the friction between two rotating surfaces. One must be kept stationary, or another one will be rotating. Due to the friction, the large amount of heat is generated. This heat is used to melt the metal, which will make the coalescence of the metal. These coalescent metal then get cooled, and the two metals get stick together. Categories of friction welding: continuous dry, inertial dry. Continuous dry friction welding. One of the workpiece is attached to the rotating motor drive. The other is fixed in an axial motion system. One workpiece is rotated at constant speed by the motor. An axial radial force is applied. In this, you see here it is a brake, motor drive. This is a workpiece and the non-rotating ways. One of the workpiece is rotating and other one is not rotating. An axial radial force is applied. These spindle, when started rotating, come into contact with this stationary workpiece. Due to the friction, large amount of heat is generated. Here are two types of force. One is a radial force and the axial force. The workpiece is brought together under pressure or for a predetermined time until the preset upset is reached. Then the drive is disengaged and the brake is applied. And the drive is disengaged and the brake is applied. Here, the upset is nothing but the bulging of the metal from its surface is called upsetting. Here, this upsetting will determine the strength of the weld, so that we need to give a predetermined time until a preset upset is reached. Yes, this y-axis is heat force upset and x-axis is time. This is the frictional speed, this is the frictional welding force, this is a forge force, and this is the upset distance. Frictional welding variables. These frictional welding depends upon these 5 variables. First one is rotating speed, the speed at which the spindle is rotated. Heating pressure. Heating pressure is while heating, how much pressure is applied. Force pressure, heating time, forging time. You can see this is the time taken during forging. Then this is the frictional welding machine commonly used in industries. Frictional welding stages: first friction, forge, then weld. These are the steel stages in welding. This is the frictional weld pattern. This is a predetermined upset. The upset will be removed after welding by machining the part. These are the joint design. you can see different types of rod, tube, rod to tube, rod to plate, tube to disc. The joint face of at least one of the workpiece must have circular symmetry. Usually the rotating part is needed to do the frictional welding. Why we go for frictional welding? Resulfurized stainless steel is normally not considered weldable. However, it can be welded by frictional welding process. Austenitic stainless steel, when compared with carbon steel, engender problems such as large amount of distortion, shrinkage, residual stress after welding. Such residual stress developed during the welding of stainless steel should be minimized. When using HAZ failure and sensitization, which is a critical problem in ferritic stainless steel weld, and due to this, weld exhibits much lower ductility and toughness. Barrier defect in fusion process stainless steel weldment. HAZ failure is nothing but heat affected zone, and sensitization when it is a critical problem in ferritic stainless steel weld. The weld will get very sensitive to the for the impact stress, so that the weld may break. So that the frictional welding is preferred in this type of metals. Inertial welding process discrimination. Inertial welding is nothing but simply the one of them where first the motor is rotated and the centrifugal force is stored in the flywheel. After that, the motor is powered off. The centrifugal force in the flywheel is used in this frictional welding. The flywheel is applied to the welding angular velocity. The drive is disengaged and the workpiece are brought together. Frictional heat is produced at the interface. The axial force is applied to complete welding. Moment of inertial welding variables are moment of inertia of the flywheel, inertial flywheel speed, axial pressure, forging pressure. This is inertial welding machine. This is when the energy is low, the upward will be like this. When it is medium, high, as same as like of energy for pressure and velocity is also given here. You can see similarities between the continuous drive and the inertial drive. In both methods, welding heat is developed by frictional heat and plastic deformation. Both methods use axial force for offsetting pressure. In both methods, the axial pressure may be seen at the end of rotation. Difference between continuous drive and inertial drive. Continuous drive, inertial drive. One of the workpiece is directly connected to the flywheel. Rotational speed remains constant until the brake is applied. Rotational speed decreases continuously to zero during the process. Rotating energy of the workpiece dissipates through friction and plastic deformation, producing welding heat. Kinetic energy of the flywheel is dissipated through friction and plastic deformation.